Okay, the E101 is just spinning down now. In conclusion to the various experiments I've tried, first of all, let's say the SE3 put up a good show in as much as they had the speed and they were able to turn the dynamo over at a reasonable rate to get a reasonable glimmer of light from the bulb. The E101 has got the pulling power, the turning power, to keep that dynamo moving. No matter how much resistance, it just kept on turning it. However, it seems to be at a disadvantage because the drive has to be taken off the top lay shaft, which is spinning a lot slower than the main crankshaft. The crankshaft, however, because it's a lot thicker, I cannot attach a mechano sprocket or pulley. I did try a train drive, which overcomes the problem of stretch and slip of a belt. However, again, we're still not getting enough revs to actually turn that dynamo over at sufficient enough speed. So, in essence, you need both speed and you need a non-slip drive, which is why MLI have devised this system where you've got a direct drive coming straight off the engine. However, that said, the only way that this dynamo will work is if there's a significant flame conflagration underneath the boiler here, which is why this engine, I believe, has been improved or modded in such a way as to put 3 very large gas jets in there to really concentrate a very hot flame on that copper boiler in order to get as much into this engine as possible. Then, only then, will I think it will work. But to be honest, my conclusion is that the Stewart engine is not up to it because you have to use such an inordinate amount of flame in order to get it to run through, regardless of whether it will run at a high RPM or not. However, the gas pipe here, I may be able to attach to a gas supply in the future, maybe using butane with a rubber hose running through to it. We'll have to wait and see. Obviously, I don't have a Bunsen burner type gas jet supply in order to try this out. So in essence, the SE3s and the E101 put up a damn good show using a variety of couplings, using a variety of gearing and mechanical advantage ratio pulleys. However, the simple fact of the matter is that this dynamo offers a tremendous amount of resistance to whatever's driving it, and consequently the only way it's going to really work is using a non-slip drive such as that, and using a motor that will run at very, very high speed and is able to be connected to a boiler which will have a very hot, very strong, consistent flame heating it continuously without any let-up, which is why I think this engine is obviously gas powered. That said, it probably will work very well, assuming that the actual safety valve has not been fiddled around with in any way, which has caused explosions on these engines in the past. My own view is that in order to show how the pent-up energy of methylated spirit or flames in the form of gas can be used to convert water into steam and steam into a driving force to produce electricity, it's a lot easier to use a smaller dynamo and in some respects to use the trusty Griffin and George SE3, which is a lot simpler and easier to use, and in many respects, certainly for my own, was a lot more prevalent in the prep labs of the 1970s than possibly the MLI engine. That said, the MLI engine is very, very well built. It'll take a lot of punishment. However, it's a little bit more specialised, let's say, certainly in its requirements in terms of flame and heat in order to deliver, certainly to this part of the experiment, to deliver enough speed, RPM and turning power to get some sort of current out of this. The SE3s did a damn good job turning it over at a reasonable high speed, but that said, I feel really that it's a little bit too big for what it actually needs to be in order to demonstrate this experiment. How these MLI engines work with the other experiments, such as clockwork motors, smaller dynamos, turbines, and other pulley systems to demonstrate mechanical advantage, I couldn't say. However, it's been interesting trying out these three quite diverse engines in order to sort of ascertain the relative merits of each against each other. I would say the SE3 comes off with top marks really, because it did everything it had to do. However, that said, it would be better if a sprocket was fitted to the SE3 and we could try that on there. That may be something to try for the future. However, the SE3, it's quite tight to fit a sprocket in there. It can be done, and maybe that form of non-slip drive will be better, assuming that you can keep a sufficient tension on the chain. So there you have it. It's been a fun few days trying out various different experiments. As I talked, the E101 is still machine gunning away in the background, and if, let's say, I could get a direct drive off that part of the crankshaft, it may be that we could have got more out of this one. But because there's such a reduction between that pinion and the actual drive pinion, the sort of gear wheel coming off it, it's a reduction of about 10 to 1, maybe more than that. We're just not getting enough revs at the power takeoff point. Even using a 2-inch sprocket running a 1-inch sprocket, you still can't step up enough of that turning effect in order to get more on there. The E101 just carried on going regardless, no matter how much resistance this particular motor put up, but it couldn't get enough revs to actually get that going. So it's been fun on the workbench over this New Year period. So we'll say at the moment that the findings are maybe inconclusive, but my leanings would be towards that the SE3 put up the best show. Certainly the E101 put up the largest amount of non-stop power, continuous power, and the Stewart ST1 engine unit in the current firing form that I was using was simply not up to the job. That's not to say with the correct firing of the boiler using 3 very powerful concentrated gas jets, it could put in a better show for itself. Something to try for the future, so I hope you've enjoyed these experiments.